Okay, so I'll be presenting number 4, where we still have the same end, I think, going on ecology grid, and want her to be back to the original point after 6 steps, not 5 steps. So still I drew all these possible ways to like go a few steps and go back to the original point. And the thing becomes trickier because when we have 6 steps, we can do 2 cycles. We can say do this cycle twice or do this cycle twice. Or we can say do this twice and do this once. So
by cycle, you mean there is one cycle in between those 6 moves, right? They're not necessarily.
Yes, basically I'm basically going on a shopping where I shop the sets of moves, and then I recombine them into 6 steps with like depth displacement 0. Okay, so this will require us to do some casework. So first we can start working with two cycles. So I can call this cycle A, cycle B. If I have two A cycles, which means I'll have 2 of this move, 2 of this move, and 2 of this move, which means I'll have 6 choose 2 times 4 choose 2 times 2 choose 2 equals 90 ways to rearrange them. And same thing goes for B choose B times 2 B cycles.
So the 6 choose 2, 4 choose 2, 2 choose 2, where does that come from?
So because we have 2 of this move, 2 of this move, and 2 of this move, so we can first like decide like where these are two moves appear. So that gives us 6 choose 2 choices.
Okay.
And then among 4 moves left, we can choose which 2 moves are this move. Yeah. So we have 2 of the same cycle. Also, we can have 1 A and 1 B.
So all moves will be different. Right?
Yeah, because all of these 6 moves are different, which basically means that it's 6 factorial. So this is okay with 2 cycles. If I have only 1 cycle, then we have 3 steps left because since these are all even, this is impossible. So we have to do a case where there are no cycles. One thing to be careful though here is that if we choose 1 of each, it's basically equivalent to like choosing 1 A and 1 B because both of them use all 6 moves. So we want to avoid that. So here I think I'll just call them PQR.
So one more time, your definition of cycle is the triangles.
Yeah, the triangles.
It's only going A and B. Okay.
Yeah.
So 0 cycle means he cannot choose all 3 types.
Okay.
If he chooses all 3 types, he basically has a cycle.
Because we're basically on this.
Right. Okay. And PQ and R don't count as cycles.
They are pre-congruent as a set.
Okay.
Okay, so which means that we have to choose one, or like at least one of these back and forths twice. So there are basically 2 cases where I'll denote by 2x plus y and 3x. So 2x plus y means x and y are two different possibilities of these 3. So we need to decide like which one is x and which one is y.
So that's 3 choices because x and y are different, right?
Yes, 3 choices for x and 2 choices for y. Because x and y are different in this case. So now say we take 2 p's and 1 q's. So we have 2 of this move, 2 of this move, 1 move of this and 1 move of that.
So we write it down.
Yeah, so like I'll call this like P1, P1, P2, P2, Q1, Q2. We want to rearrange these 6 letters into a string.
So technically it's this guy.
Is this yes, it's this thing, but not and when we have like only 2 Q's that we can rearrange them. So which means that this gives us 6 choose 2 times 4 choose 2 times 2. I think this is 1008.
Why do you multiply by 2? Sorry.
Because 6 to choose 2 is the way to place this.
Yeah.
4 choose 2 is the way to place this, and 2 is the way to rearrange these 2.
Q1 and Q2 are 2 different.
Q1 is this one, Q2 is this one.
So I think it's much better is all these moves, we don't look at them as 6 choose 2 or 4 choose 2. I'd rather think that them as what? You have 6 objects, now you're dividing out what? The
6 factorial.
So 6 factorial over
2 factorials and 2 factorial.
Yeah.
Right? And this one is 6 factorial over 2 factorial, 2 factorial, 2 factorial, because each one of them repeats.
This is equal to 6 factorial, 2 factorial. Right. Okay, so let's go to 3x. So once again, we have 3 ways to determine x. So now we basically like say we choose p 3 times. So now it becomes p1, 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 p2, p2, p2.
And that's 6 choose 3.
And
6
that's-
factorial over 3 factorial, 3 factorial, right?
Yeah, so and this gives us 60 ways. So now it remains to add all these cases, which gives us 90 times 2 plus 720 plus 1080 plus 60. This gives us 2040.